So I just want to say that most of the time, GPS people, or GNSS people talk to GNSS people. And I think in this session, we need to expand the scope of that a little bit. And being from NASA, of course, I'm focused on space exploration, space operations, science applications. Many of the benefits that we get from remote sensing come from space platforms. And so I wanted to kind of mix in a little bit, what GNSS can do in the space arena, in the space domain. So with that, is the chart set for NASA ready to roll? Whoever's in the back. There we go. Thank you. Okay, so as I just said, Artemis partnership opportunities, GNSS policies and modernization update, and building on international collaboration. So this is kind of the themes that I wanted to bring together. And really, GNSS is the linchpin. MGA is really focused on that. But I think over time, it's going to be up to all of us to bring in some new dynamic, innovative ideas, besides just GNSS applications, but how do we serve society as a whole? And again, using space as a great platform. So if we go to the next chart. Okay, of course, I had to put this commercial in. Everyone is very familiar with Apollo. I grew up in the 1960s and 70s, so I do recall watching Buzz Aldrin walking on the moon back in 1969. And hopefully some people in here do as well. However, we now have Artemis, and it's not as familiar a term, but Artemis is the sister of Apollo in Greek mythology. And so it actually reflects the new human space flight series of missions that will take us to the moon and beyond. And so I think you're all familiar with the fact that we just did our first flight around the moon. That was an unmanned flight in the fall. Our next one will actually be crewed. It will fly around the moon further than ever before, further than Apollo 13, which everyone is familiar with. And then the next one following that, 2024, 2025, will actually be a third mission where we'll land someone on the moon. And we're really focused on diversity, greater representation of planet Earth. And so that would mean a woman and person of color to join in this very small group of individuals who really have this grand opportunity to step on another planet. So just wanted to point out that Artemis is our new space program, but a lot of what we do is we're going to be using GNSS to get there. And we get the question all the time, why do we need GNSS? We didn't need it during the Apollo years. Well, why do you need an iPhone? Why do you need an electric car? I mean, this is new technology that we all should be advancing and capitalizing on because it's safer, it's more robust, it's resilient, and it gives us layers of layers of new capabilities. So if we go to the next chart, the Artemis Accords are basically principles that came out of the 1967 Outer Space Treaty. And really, they are intended to be responsible use of outer space. We don't want a Wild West scenario. And so, of course, we're going up there for peaceful purposes. We want to be transparent. We want to ensure interoperability, emergency assistance. We actually do search and rescue through GNSS satellites at this point. And so the ability for an astronaut to have an emergency beacon is actually being developed at NASA. And of course, we want to make sure that we have transparency and release of scientific data that benefits all of society. Let's go to the next chart. Bottom line, this is what I had talked about initially, and that is our journeys through 2025. So you'll see at least 2 to 3 more. And the end result is that they will actually begin to build a lunar base on the South Pole because there's water ice there. And so besides sustaining life, there are things that you can do, such as actually develop rocket fuel. So the technology is far off, but we know that the core resources to be able to do that are located in this geographic region on the moon. So if we go to the next chart, I think that we talk a lot about the applications and the capabilities of these GNSS systems. But in order to do that, we really need money. And you get money by working with policymakers. And so myself, I'm a policy analyst. I work a lot with other agencies in the White House. Some of you are very familiar with this. This is the National Space-Based P&T, Positioning, Navigation, and Timing Advisory Board. And so GPS itself is managed by the Space Force. It's the executive agent of space for Department of Defense. But we all know it's a dual use system. It's not just the military system, it's also for the civilians. And they, of course, are the majority of users. So we have this executive committee with all these departments, 13 departments on the left that actually oversee it. It's co-chaired by Department of Transportation and DOD. And then you'll see to the far right, this advisory board. And this is one of the boards that I manage on behalf of the government. And this consists of a lot of GNSS experts that many of you know. We have international representation. We feel it's important. And these are all users. These are people that are brought in as individual experts that let the government know you're either on the right path or you're on the wrong path. And they develop recommendations and findings to kind of steer the government sometimes in a new way, or sometimes reaffirming that what they're doing is working very well. So let's go to the next chart. This is a second advisory board that may be newer to some people, but in the United States, we have what's called the National Space Council now. It was developed during the last administration. It's been around on and off since 1958, but it's actually chaired by Vice President Harris. And so it consists of the cabinet level. So this is actually everyone that reports to the president directly. And then we have a, oops, I was on the wrong chart somehow. This is the advisory board I just spoke about, so I don't need to repeat this. So let's go to the next chart. And this is what I'm talking about. So this National Space Council also has an advisory group, which is, it consists of users and constituents. And the interesting thing here is these are the CEOs of almost every major space company in the United States, as well as smaller companies. And the reason is commercial space is doing phenomenal things with the economy, right? There's an entire new market of commercial space that's evolving, job creation. It further pushes STEM, science, technology, engineering, and math training. And so this is a group that actually has GNSS as a cornerstone, as a part of it, because people like myself live in both worlds. And so again, this kind of sets the stage. How do we get money? How do we get government agencies and the private sector and academia interested in what we're doing at MGA? It's forums like this where we've got private citizens actually becoming advocates for their own requirements. So if we go to the next chart. This is the basic chart that everyone in here has seen many, many times. The bottom line is, including the newest launch in January, we've got 38 satellites up there. Everyone knows the core constellation is 24 plus 3, so 27. And these satellites are living much longer than they were originally intended for. So this is kind of a mixed blessing, right? We launch as needed. And so sometimes we'll have an older performing satellite, but it doesn't make economic sense to push it out of the way. And so we keep it up there. And then the challenge is, how many more can we fit within this very crowded meal belt? But as you can see from the bottom section, the user range error is still very, very good. But there are competitors out there. Let's call them partners, and we compete on a friendly basis. And so Galileo and GLONASS and Beidou may very well be starting to perform just as well as GPS. And so we have to continue to support each other, but also continue to try to excel and compete with each other so that we can make sure we've got the best of both worlds with all the systems out there. So next chart. This just is a quick run through again of something that most people are familiar with. GPS-R or replenished, GPS-RM replenishment modernized, GPS-3F for follow-on, and GPS-3. And you can see that each block of satellites is improved a little bit. Maybe it has a longer lifespan. Maybe it has an additional signal on it, the L2C or L5. And finally, with GPS-3, we have L2C along with L1CA. And so we actually have multiple civilian signals. But what happens is you're able to get some military type capabilities because the military always used more than one signal, right? They were able to make some corrections, processing more than one. And in this case, we could do trilaning and just a variety of techniques because you've got more signal variability to work from. So let's just, in the interest of time, keep moving. These are just a snapshot of some of the contributions that NASA has made working with the Space Force. Of course, it's a Space Force system, but NASA has payloads on GPS, and we play an important role in the regulatory regime with protecting the spectrum. That's one of the key things for all of us. We have to protect what we have before we can really go out and develop new capabilities. GNSS signal monitoring. Many of you are familiar with the International GNSS service and Global Differential GPS. I know that this particular body, has an entire program on signal monitoring of all the constellations. This remains very important. And then on the satellites themselves, NASA has put on laser retroflectors with SV. It might be a little bit earlier, SV11. We might be able to get it on SV9. We're going to have retroflectors on there. Of course, being able to do laser ranging and compare that to your radiometric data. Over time, you isolate and exclude the systematic errors, and you can improve the terrestrial reference frame. So it makes the entire system tighter and more accurate. Search and rescue on MEO, much more capable than the old COSPAS-RSAT system that used combination of LEOs and GEOs. And of course, GNSS space service volume. We're going to talk a bit about this tomorrow, so I don't want to get too far into it, but bottom line is we started using GPS for missions out to GEO, 36,000 kilometers, and we are now using it in the cislunar domain out into the lunar mission applications. So we'll talk more about that tomorrow, but it's quite amazing because we all know GPS was made for terrestrial aviation and maritime, not for space. And yet here we are exploiting the signals for big space use. So again, let's move on in the interest of time. And a 1 and a 2 and a 3. Are the slides stuck? Oh, they are? They're frozen? Okay. You want to take a second? See if you can get them going. Love this new technology. All right, good enough. I really appreciate that, especially when we're on virtually. Okay, so this gets back to a little bit of what I said about the laser retroreflectors, something very simple like mirrors on a satellite and the great benefits that it brings is just an example of how we're putting some trial equipment on, and actually it creates a circle of improvement. And now we all know we're using GNSS for radio occultation, for weather forecasting, to measure ice melt, to measure sea level change. It's actually a very critical weather forecasting tool, and it's allowing us to do climate change monitoring in a very unique way. Early warning tsunami alerts, and many of you have heard, some of these things before, but it's important to remember because again, talking to the policymakers, GPS or GNSS is way more than just a blue dot on your iPhone. Next chart. This is kind of my end of the presentation, but the bottom line is we cannot succeed in this world of emerging space or GNSS without each other. And so the International Committee on GNSS, it's under the COPUOS umbrella, Committee on the Peaceful Uses of Outer Space. It basically gives us an opportunity to work together. It takes the best of the bilaterals that America has with other nations. And if we go ahead and go to the next chart, it brings them into one particular forum. And so in this forum, hundreds of people involved from all the P&T service providers, but also from space agencies that just have a particular interest in seeing different applications and techniques developed. So our last one was just in UAE, and the next one is coming up in Madrid, Spain in October. So there's plenty of planning time. But because it's in Europe, it's halfway almost for all of us to get there. We strongly recommend that you find out who your delegation leads are and attend. And we are trying to get more industry representatives to participate because government representatives like myself need to hear from our commercial sector. So let's go to the next chart. Some of the key ICG initiatives, how do we agree on really what are the metrics that we're all going to be using and measuring against? We've got the traditional, accuracy, availability, continuity, and integrity. But there is much more we can put in there as these constellations expand. GNSS signal monitoring, again, becomes more important because GNSS is a stealth utility. It's built into so many critical infrastructure elements that we don't even fully understand the scope of that. And so it becomes all the more important to monitor and then provide alerts on integrity as we move on and it continues to be adopted. We all work on different reference frames and timescales. So how do we connect them all together? That's an important consideration. We talked about search and rescue, and we talked about expanding the space service volume. So let's continue. The outcomes of the last meeting, one of the ones I'll just point out here is this lunar P&T. Can we really process signals out to lunar distances? We're very confident that we can. We're halfway to the moon right now with the heliospheric mission, and we're getting 5 to 6 satellites in view halfway to the moon. That is just phenomenal performance because we have weak signal tracking receivers. They were specially built to track signals of that power level, the lower level power level. If we go to the next chart, just the summary, the U.S. finds that partnerships are not just nice, but required. We're now in a new age where we have to continue to strengthen that. We all need to protect the spectrum, make sure we're interoperable. We want to enhance the capabilities so they benefit all of us. And we want to mitigate the vulnerabilities. And so the GPS or the P&T board has adopted protect, toughen, and augment. That's pretty self-explanatory, but it will never go away. And the next chart, simply my contact coordinates. Happy to take any questions now or later when we complete all of the presentations. But I want to thank you. I ran over a little bit. I apologize for that. But that concludes my presentation, and thank you very much. Okay, so I had a little bit of a program here, and I've got Dominic in the audience ready to jump up, but I want to check with the reps in the back. Do we have virtual connectivity with those other presenters that plan to be on today at this session? Can someone like
Roscosmos is
do
here.
jumping jacks or something to let me know? Okay,
Good
I'm
day,
not getting.
James. Good day. It's Ivan Renew speaking. So yes, I'm online. Can you hear me well?
Ah, yes. Ah, right. Okay,
James, yes. Good day to you. Can you hear me well?
Ivan can hear you
Yes.
very well. Thank you very, very
Perfect.
much.
Perfect. Perfect.
You saved the day. So I'm very pleased to introduce our GLONASS Roscosmos colleague. And so Ivan, over to you. Thank you.
Actually, it is blocked from your side to share my presentation. Can you check it? So
Can you?
it's blocked by organizers I can't share my presentation.
Yeah, I think we've got, let's see here, 1, 2, 3, 4, 5 people working to get your charts up, I believe.
My charts, I didn't download them. I will share it from my laptop.
Okay, I think that might be a better route. How many people does it take to load a PowerPoint? We'll find out.
Okay, yes, now I can. So okay, perfect. Can you? Okay, I'll turn off the video. Okay, so
Oh,
now
wonderful.
wonderful. So you can see my presentation. So yes, thank you, James, again for leading this section and also for the organizers of this excellent conference. So Ivan Revenue is speaking as a representative of Roscosmos State Space Corporation. And of course, it's a great pleasure to do my brief presentation here today and make some short updates on the GLONASS status. Yes. Yes. Okay, perfect. So the full GLONASS constellation consisting of 24 GLONASS medium Earth orbit satellites is now operational and ensure approximately 100% availability. Last year, the launches of GLONASS K satellite in July and October have been successful. So now, for navigation satellite in orbit belong to this third generation batch of GLONASS satellite, besides the last GLONASS M satellite, was successfully launched in late November. Overall, for the last 5 years, the GLONASS constellation has been renewed by a third. Another 6 GLONASS K satellites are planned to be launched by the year 2025. So nowadays, we provide 4 GLONASS civil services. Any user in any region of the world can access GLONASS basic service. It's a PNT service provided by GLONASS, 3 open signal broadcast by GLONASS space segment. Our service is improved reliability and accuracy, provides users in Russia with the differential and ionospheric corrections, as well as integrity based on the system for differential correction and monitoring, the SDCM system. So I will address this operation in detail a bit later. And also the relative navigation service, which is based on the regional and local networks of ground stations. Speaking about the high accuracy service, we are currently provides the users in Russia with point precise positioning corrections, which are transmitted through the ground network. So the launches, our constellation is capable to broadcast L3OC code division signal is greatly growing. By 2025, the GLONASS global adaptive ionospheric model will be introduced to navigation message and interface control document. For L1 and L2 frequency division signal for better position and accuracy. The full-scale deployment of the GLONASS-K satellite enables us to run inter-satellite radio links for ranging and prompt dissemination of excessive information. It's also important to mention that 5 GLONASS-K satellites will carry COSPAS-SARSAT payloads, contributing to international search and rescue requirements. So, moreover, all GLONASS-M and GLONASS-K satellite carry laser reflectors that inter alia promotes the operations of unbased space geodetic facilities. So, according to our assessments, the current GLONASS position availability is at least 98% in any place of the globe. Our assessments of GLONASS signal and space user range and error for 3 months shows that it remains lower than 1.6 meters in most cases. Let me remind you that this accuracy characteristics illustrates an aggregate error caused only by operations of the system and does not take into consideration other variable errors, error sources like ionospheric delay, multipath, and receiver noise. So we plan that our further modernization effort will reduce the improved GLONASS performance significantly. So on the next slide, I will speak about differential correction and monitoring. So 50 SDCM measurement stations in Russia and neighboring countries continually collect and transmit measurements data used to perform real-time differential correction and integrity for the GLONASS and GPS, as well as ionospheric corrections based on vertical total electron content and grid parameters. The information is uplinked to the 2 geo-LUCH relay satellite and broadcast to the users in the service area. Currently, the SDCM is based on S-bus L1 technology. However, by 2030, SDCM will embrace DFMC S-bus technology and transmit dual frequency corrections for all GNSS via L5 signal with the help of payloads installed on board of 5 new Russian geo satellites. SDCM certification in accordance with APV-1 and APV-2 is in progress also. Tests in Moscow region have confirmed compliance. The finalization of certification is investigated by 2030. Yes, that's not fast. So on this slide, I will speak about the high accuracy service, which is experimentally operational and capable to provide orbit and clock corrections for all GNSS. By 2030, it will it will be available via both ground and space-based channels. The latter will be ensured with the help of new Russian GEO Luch 5M relay satellite broadcasting L3 signal designed for the transmission of precise point position correction. The further development of GLONASS high accuracy service is planned to focus on the incorporation of ionospheric corrections, ambiguity resolution, integrity, and new message form similar to compact SSR. So here on this slide, you can see how the GLONASS is currently used in Russia, basic application. Apart from conventional applications such as aviation, railroad, maritime, internal waterways, and precise agriculture, infrastructural synchronization or monitoring utilizing the GLONASS civil services are widely used. The use of GLONASS in innovative prototypes of self-driving cars and trucks developed by Yandex, Kamaz, and other Russian companies, it was special attention. Our nationwide emergency system of the Euro GLONASS is saving lives in car accidents also, and also in the car accidents and other distress situations. So the Roscosmos State Space Corporation, with the help of other Russian government agencies, is making significant effort to assess GLONASS characteristics, confirm their accordance with the guaranteed levels defined in GLONASS Open Service Performance Standard, and ensure that GLONASS domestic and foreign civil users are provided with a PNT service of proper quality. So moreover, the Roscosmos State Space Corporation is providing both foreign and domestic users with extensive information support through its applied user center based on information and analysis center for positioning, navigation, and timing, the chief think tank in satellite navigation. So the GLONASS role for sustainable development, which is almost my last slide. So now I'd like to emphasize that the Russian Federation firmly adhere to the consistent policy to provide GLONASS basic service unlimitedly, free of charge, and with global guaranteed and selective availability. We believe that this policy facilitates quality of different nations utilizing the satellite navigation and support developing countries. I would also like to make an accent that GLONASS civil service promote achieving a number of sustainable development goals. In this regard, Roscosmos is committed to developing GLONASS and its civil services for the benefit of all humankind. Apart from that, I would like to point out that for the bilateral and the multilateral cooperation in satellite navigation is undoubtedly a priority for all nations, since civil services of all navigation satellite systems are jointly used through the world, and including in the developing countries. Joint search for solutions of common issues and new capabilities within the bilateral and multilateral cooperation facilitates enhancing the quality of navigation for all users globally. So thank you very much, and I also will participate in the Q&A section a bit later. Thank you, James.
Thank you very much, Ivan. Let's please give him a hand, please. So we know it's not easy to present virtually, so truly appreciate your contribution here. And again, all these session presentations will be available for those that are interested. For the next speaker, we've got a colleague and friend of mine, Dominic Hayes, who most of you know from the European Commission. I'm going to give up my step stool here since I'm 6'2" and soon to be 5'6" again. And so over to you.
Thanks, JJ. So can we pull up my slides, please? And I'm not going to stand behind this because I prefer to present while I'm walking. And as I've got a microphone that's mobile, why not? Also, I can see my slides. So I'm Dominic Hayes. I'm from the European Commission. And maybe those of you that don't know, the European Commission is the executive body that's responsible for Galileo. The European Commission itself is like the civil service of Europe, or the civil service of the European Union. And the European Commission is one of the institutions of the European Union, along with the European Parliament and the European Council. And the European Commission is the, if you like, the strategic and political direction for the Galileo program. In fact, it's not a Galileo program anymore. It's actually an EU space program, and Galileo is one of the components of that space program. Next slide, please. So I'm required to give this statement because I work for the European Commission, and when we attend a conference at which Russia is present, we are required to give this statement. I won't read it out, but I will say that the EU, along with its like-minded friends, will do what it takes to ensure that Ukraine can determine its own future. Next slide, please. So Galileo today is composed of 28 satellites in MEO orbits. It has outstanding performance, and the next slide will show the performance. We have a number of operational services, and we're rolling out some new services in the coming years. The most recent of which is the high accuracy service, and that was declared operational last week, in fact. Our Commissioner, Thierry Breton, announced it at the Brussels Space Conference. And so that's the start, we hope, of a very successful service. And I will talk about it later in the presentation. We have a very strong link with our users, also the market and industry. And I emphasize users because it's all very well having a satellite navigation system, but if you don't have users, there's no point in having the system in the first place. So we have very strong links with our users. And despite having a really successful satellite navigation system up there, Galileo, we are working on the next generation. Next slide, please. So this is the slide I mentioned that talks about the performance. So you can see here, the green arrows at the bottom there show the signal in space user range error. And we are, if you look at on the right-hand side, you see the constellation average, the green arrow there, it's around 20 centimeters. Now, this is the ranging error from the satellites. Now, that 20 centimeters has been quite consistent now for the last few years. And it will stay around that, maybe improve slightly. But you can see from the other back, yeah, you can see from the other systems there that we are actually very competitive compared to the other systems. So we think we actually have the best performing satellite navigation system. We may need to work on reliability still. We are still working very hard on that. We had an outage several years ago. We're working very hard to make sure that doesn't happen again. Next slide, please. So I mentioned that we have a number of services. Now, this is the portfolio of our services. So we have the open service. That's the one that most of you will pick up on your smartphones. That open service is available on 3 frequencies. So if you have the right equipment, you can actually pick up 3 Galileo signals and do something called tri-laning using the 3 frequencies. And we're continually improving that performance. We're introducing a new service next year. I think it is going to be declared operational. This is the emergency warning satellite service. And again, I'll have another slide on that later on in the presentation. We're also working on new features for the next generation, advanced timing, and as Jim mentioned in his presentation, we're working towards the SSV definition for the Galileo system. So that will mean that you can use Galileo in orbits from the GEO downwards. We have a public regulated service, which is available for EU member states. It's a robust and encrypted signal for governmental applications. We have the search and rescue service. That is part of the Cosmos SARSAT system. It's been operational since 2016. It's saved many lives over the years. That's using the forward link. So that's the link from the beacons, the distress beacons back up to the satellites and back down. We also have now a return link, which is operational. This is where a beacon can receive a message from the rescue coordination center to say that the rescue message has been picked up. So if you're in a sinking ship, this will give you some hope that help is on its way. And we have 3 additional features coming to the search and rescue service. So we have the RBA, which is the, I'm trying to remember the acronyms now, remote beacon activation. So this is where an authorized authority can activate or request to activate a beacon. So for example, if you remember a few years ago, the the Malaysian Airlines aircraft that went missing, it turned off all its transponders. In this situation, if an aircraft was feared lost, the airline could request that the beacon be turned on, be activated. And in that case, you could actually track the aircraft through this remote beacon activation. We have TWC, which is two-way communication. So this is where messages can be sent from the beacon to the rescue center, messages such as I'm sinking or I've got someone who's in danger of dying, or some predetermined message that could help the rescue service. And then we have the DPS. This is a direct position sharing. So if you are on a ship that's maybe quite close to where another ship is sinking, that could actually be activated and be given the position of where there is a sinking ship or any other emergency. And if you are closer, you could potentially get to that beacon before the official rescue services. So this is another feature that we think will save lives. I'm going to talk about the high accuracy service a bit later, but we've also got authentication. The open service navigation message authentication is coming soon. And then we're also working on the advanced signal authentication services. So that's using the 3rd frequency, the Galileo E6 frequency. It will be an encrypted signal, not quite as robustly as encrypted as the PRS, but it will be encrypted so that only registered users can receive authenticated position fixes. And then we have the safety of life contribution, which is working with the other systems to provide ARAIM capabilities, both from Galileo satellites and also through our EGNOS system, which is the regional SBAS system that covers Europe. Next slide, please. So this is our roadmap for 2023. In fact, it's a little bit out of date already. You can see from the 3rd bullet there, declare service for high accuracy service. Well, we've already done that. I mentioned that. We've done that last week. But the other things we have on the roadmap, the to-do list, if you like, for 2023, is to consolidate the constellation to ensure that we have at least 1 spare satellite per plane. We also want to complete the ground segment this year. We also want to declare the open service navigation message authentication in service. That will be coming very soon. And we planned a public demonstration campaign for the Emergency Warning Satellite Service, EWSS. And we're also going to be publishing documents to update all of the services that we we are providing. Next slide, please. So the high accuracy service, our newest service. So we've actually been transmitting the signal for quite a while now, and it's been in test phase. But last week, as I mentioned, we've declared it operational. It provides orbit and clock corrections for the Galileo signals, so E1, E5A, E5B, and E6. But as well as that, it provides corrections for the GPS L1CA and the L2C signals. So it will be providing corrections for all of these, and you can combine that with the information you get through your regular satellite navigation, satellite reception, and you can get a more accurate position fix down to around 20 centimeters. In fact, I think we can go even lower than 20 centimeters, but 20 centimeters is what we are advertising. Now, the key thing compared to some of the other high accuracy services that we've spoken about during the conference is that this one is coming from a MEO constellation. And compared to a GEO PPP correction, you will get the convergence time on your device more quickly. So typically from a GEO, I think I've heard figures of about 30 minutes for convergence once you pick up the signal. For the Galileo HAS service, we're looking at a conversion time of around 3 minutes or so, which I think is very good. There are a number of LEO PNT systems coming along in the future. When they come, that will improve that even more. So I think you'll get fairly fast position fixes, high accuracy position fixes in the future. But obviously, this is what we are doing now. It's operational and it's something that we're very proud of. These PPP signals, the corrections, are provided free of charge using our third frequency, the Galileo E6 frequency. And I have to say now, one of the things I'm working on is at the World Radio Communication Conference, which is this year, later this year. It's an international conference where we modify the radio regulations. One of the things we want to do is get additional protections for E6, because at the moment it suffers or can suffer from interference from other services in the band, notably the radio amateur service, which is a secondary service in this particular frequency. But it's something that we think is very important. If we're going to use this for service in the future, we need to have a reliable reception. So we want to improve the regulatory protection for E6. And we know that Japan, the QZSS community is very supportive of this agenda item for the conference. I just wanted to mention that. The corrections will also be provided over the internet. And actually, this provides some very interesting possibilities in the future. I was speaking to a colleague and I said, well, does that mean if you have a handset that can pick up the internet, but it's only got one GNSS frequency that you can get a high accuracy position fix? And he said, potentially, yes. So I think this opens up the door to a lot of opportunities for PPP corrections to handsets. He did say that you won't get the full benefit of the triple frequency performance boost that you get from the PPP provided by the satellites, but it will be a high accuracy service better than you can get with just the GNSS on its own. Next slide, please. The next service, which is coming very soon, is the OS-NMA, so Open Service Navigation Message Authentication. It's long awaited. I've been talking about authentication for many years, but now it's finally happening. We've had the ICD for the OS-NMA out for several years, well, since November 2021. The signal itself has been transmitted stably on the the E1B signal, well, over a year now, because this slide is slightly out of date. We anticipate this service to be declared operational in the first half of this year. So certainly before the summer, you should see OS-NMA. We know that there are some already receivers on the market, so it's manufacturers are waiting for this to arrive. It's going to be the first authentication feature of any GNSS system. So I think it's going, and again, opening up a new potential market. Next slide, please. The emergency warning satellite service. So this is something that we've created in response to the United Nations Disaster Risk Reduction Program. It will enable an on-demand broadcast of alerts and guidance to those populations at risk from natural disasters. An alert can be activated by an authorized national civil protection authority. We plan some demonstrations of EWSS this year and service declaration next year. We've joined forces with QZSS to develop a message structure, so a common message alert format that can be used by QZSS, Galileo. We know that NAVIC is also interested in using this, and maybe other systems as well. So that's thank you to my colleagues in the Cabinet Office for helping us to coordinate that activity. So we need to make the most of that now. So we need to share and promote this common format in international forums, but also potentially not just satellite navigation forums. Potentially this could be a message format that could be used in other emergency warning channels, potentially through terrestrial means, for example. We need to demonstrate EWSS to show that it's actually a realistic system. We need to involve actors and engage those civil protection authorities that will be the ones that are requesting the activation. Next slide, please. So we have a strategic vision for Galileo. It's to maintain excellence and resilience in provision of satellite navigation services. So we need to make sure that Galileo can evolve. We need to make sure that European industry is competitive in supporting Galileo. We need to make sure that in Europe, we have no weaknesses in our supply chain, so we don't rely on any one avenue for enabling Galileo, whether that be within Europe or outside Europe. We need to identify backup and complementary PNT solutions. They might not be satellite. 5G, 6G, maybe LEO PNT. These could all be potential backup options for GNSS. We need to support market adoption. Galileo is now in over 2.5 billion devices worldwide. We need to make sure that continues and that it's adopted in as widely as possible. We need to make sure that Galileo is a leader in segments where it can make a key contribution. And we need to ensure Galileo's leadership in space. Not just Galileo's, but the EU's. I mean, we are, I think, one of the leading nations, along with the US, China, and Russia, are all leading in space. We need to make sure that continues, both through international cooperation and through bilateral discussions. And we need to make sure we're in the mix for the very latest technology that's being used in GNSS. Next slide, please. So I mentioned that we're not stopping there. So the next generation of Galileo, which we are calling shortly G2G, that's just the short form being used at the moment, will offer new signals, faster acquisition, more robustness, the capability to be reconfigurable. It will have orbit raising capability on the satellites, inter-satellite links for robustness, and we're having additional onboard clocks. We've seen how key the atomic clocks on satellites, on satellite navigation satellites, are really crucial. It's not a secret. We have had some problems with the atomic clock, so we realize that's a key facility that we need to keep and improve on satellites. We will have a number of slots, onboard slots for experimental equipment. So potentially we can add new features to the satellites as they're being rolled out on the production line. So it won't require a complete redesign of a satellite. We can slot in potentially a new feature. The current satellites, I think, have a lifetime around 12 years. We're looking to extend that to 15 years with the next satellites. I mentioned that they will be flexible, to be reconfigurable, and that's to really adjust to market demands as the markets develop. And all of that is supported by our strong R&D program under the EU's Horizon Europe program, which supports these developments. Next slide, please. I think it's the last one. Yeah. I know that there are some countries within ASEAN that are looking or considering to build an SBAS system. But I'll leave this thought for you. I think SBAS works best with cooperation. When we built EGNOS, we built it with the cooperation of all the member states of the EU, even though some of them could have done it themselves. Australia and New Zealand cooperated to build the Southpan system. The African Union is now working to build a pan-African SBAS, again, through cooperation. So I think as ASEAN should also consider cooperating to build a regional system. And you can talk to me or talk to some colleagues back in Brussels about how you can achieve that. Thank you.
All right, everyone. I realize that if you're into GNSS, this is a great synopsis, and if you're not, this is a turbo punishment. So we're moving right along. And we have our Chinese colleague on the line ready to go? My technical support in the back. Do you have a connection with CNSA?
Okay.
Ah, fantastic. And whenever you're ready, sir, you just take it away.
Distinguished guests, ladies and gentlemen, good morning, good afternoon, good evening. I'm Li Zhouhu from CSNO. Next, I'm going to present the latest development of BDS construction, and since our last meeting, my topic is the Beidou navigation satellite system construction and development. Includes
ยกมาทั้งหมดเลยป่ะดี thank you อ๋อ
The first part is the system status. Currently, there are 45 satellites on orbit, including 15 BDS-2 satellites and 30 BDS-3 ones. All the satellites provide reliable services and in healthy state. BDS provides services of 7 types, includes PNT, GSMC, SAR, RSMC, PPP, SPAS, and GAS. Based on innovative constellation, inter-satellite links, and single system optimization, BDS service performances fully meet or exceed the requirements. The number of visible satellites in the Americans remains 6 to 8, while reach 20 in Asia Pacific region with better performances. We also continuously concentrate on application infrastructure construction, establishing 4 major BDS service platforms to promote the combination of multi approaches with the BDS service. The first one is BDS short message communication service platform. It realized the combination of BDS short message communication into smartphones and interconnection between ground mobile communication system and the network. Without TD SIM card, without TD mobile phone numbers, and without any external equipment. Now, BDS short message communication entry smartphones is in actual test phase. The second one is BDS satellite-based augmentation system service platform. Now the platform is in stable operation. Civil Aviation Administration of China is carry out the certification of the BDS-based single frequency service and to be finished within 3 years. Some provide BDS space single frequency aviation service. The BDS standardization working group has been working with Euroclear and RTC in aviation equipment development. The third one is BDS COSPAS SAT service platform, which provides users with the distress alert information access and distribution. Upload the operation status of BDS SAT payload to COSPAS SAT and then provide the written link service that would increase confidential of people in emergency, facilitate search and rescue activities, and also lower the alarming rate. The platform is carry out joint debugging test. The last one is BDS ground-based augmentation system service platform. Real-time mid-level, decent mid-level, centimeter level, and post-processing millimeter level services can be provided in China. In 2022, China's State Council Information Office published a white paper titled China's Beidou Navigation Satellite System is a New Era, following displacing the development process of BDS, laying out the continuous and stable operation compatibility, world-class service performances, large scale and sustainable applications achievements. The second part is applications. For mass market applications, GoldMap has used BDS satellites to make more than 210 billion positioning calls each day in November 2022. Currently, the enterprise officially launched a series of BDS-based services, including the lane-level navigation, traffic light reminder, real-time location sharing, and so on. Beidou Maps announced an official switch to BDS, and its BDS-based Beidou Map positioning open service platform is providing services for users engaging in the auto driving, finance, logistics, traveling, IoT, and so on. On 30th July 2022, BDS short message communication firstly realized satellite communication compatibility on smartphones, and users in Asia Pacific region would have access to it. Since 21st, last September, BDS short message communication has entered into actual testing phase. Users with Huawei Mate 15 smartphones have access to the test and verification. In transportation, more than 8 million BDS supporting terminals rested in the world's largest dynamic transportation monitoring system, which realizes the 100% coverage in business areas, such as public service vessel and coastal navigation equipment. In agriculture, over 1.46 million intelligent agriculture machineries supporting auto steering and remote management put into applications. By using BDS-based agriculture machinery auto steering devices, farmers can optimize the agriculture investment and maximize agriculture production and benefits. Last year, over 900,000 intelligent machineries with BDS generated more than 200 trillion big data, empowering China's summer and autumn harvest seasons. In electric power industry, Beidou services are applied with more than 318,000 devices and terminals in total. In forestry resource management, with the help of BDS, Internet-aid forestry mode is established, improving forestry information network coverage. BDS-based products have been exported to and used in more than half countries and regions in the world. BDS has been widely used in Asia, South Asia, Eastern Europe, Western Asia, Africa, in land ownership confirmation, precision agriculture, intelligent port management, and so on, promoting local economic and social development. Especially in Asia, BDS helped the Thailand Department of Lands in establishing grant-based augmentation system and helped the domestic supply inventory via BDS-GNSS service receivers. In Indonesia, BDS-based laser radar aviation management system was widely used in the mapping and survey in new capital airports construction. In 2019, in China Asia International Tourism Assembly, the BDS terminals equipped on receive vehicles provided important support to the judging. In Sri Lanka, BDS high precision products were used in its drilling, pipeline design, and seabed elevation, improving working efficiency. In 2021, BDS donated 30 BDS-3 smart handheld terminals to Thailand, applying for tourism, transportation, and disaster relief. The third party is international cooperation. BDS also concentrates on bilateral cooperation in compatibility and interoperability. In China-Russia bilateral cooperation, the 9th China-Russia Satellite Navigation Case Strategic Cooperation Project Committee was held in the 2022. and innovative and integrated development of BDS and GLONASS was comprehensively promoted. The cooperation in compatibility and interoperability, space and civil use industries with the US were also promoted. And we also coordinated with EU to foster a communication mechanism between Galileo and BDS. In 2021, we held BDS cooperation forums with Africa, and Central Asia countries, sharing BDS construction and development achievements with the whole world. In the last October, Chinese delegation participated in the ICG 60th meeting in April, making presentations in Anjima, LU painting, space debris disposal, space weather, lunar navigation, compatibility sections. We also actively participated in programs and activities under United Nations framework to promote GNSS compatibility and interoperability. In the last October, training courses on the satellite navigation and remote sensing applications in China and South Africa was held, getting positive response from all works in South Africa. The 30th China Satellite Navigation Conference is going to be held in Beijing in May this year, with BDS GNSS High-Level International Cooperation Partnership Summit hosted in the same period, and we warmly welcome you to participate in person. BDS continuously participates in the standard systems of relevant international organizations such as IMO, ICO, COSPASASAT, IEC, 3GPP, RTCM, and so on. In the last November, the IMO Maritime Safety Committee adopted a resolution to approve the Beidou message service system for use in GMDSS. Beidou's join will enrich the distress and safety communication approaches and upgrade the search and rescue efficiency, safeguarding maritime security globally with other GMDSS. Still in the last November, in the 67th COSPASASAT Council, China familiar becomes the provider of COSPASASAT space segment. With other providers, China will provide Chinese solutions to the improvement of distress alert and search and rescue capability globally. The last part is the future visions. Going forward, we will focus on the research, development, optimization, and the launch of the backup satellites in accordance with the requirements. Also, the ensure of stable and continuous operation of the system, upgrade on system performances, and provision high stable, high reliable, high secure, and high quality space-time information. And efforts will be done in the combination of new technologies such as mobile communication, AI, big data with BDS. Meanwhile, China will build a more ubiquitous, more intelligent and more intelligent national comprehensive PNT system. Why? Ensuring the stable operation of BDS by 2035. In the last, we will adhere to the development concept of China's BDS, world's BDS, continuously promoting BDS development and giving more contributions to the social development and the construction of the community with a shared future for mankind. This is the end of my presentation. Thanks for your continuous attention and support to BDS.
Okay, thank you very much. We've all heard death by PowerPoint. I think tonight we're killing everyone by GNSS, but hopefully you can see there are a lot of common themes here in terms of partnership and interoperability. So in the interest of time, do we have our Japanese colleague present and ready to do his presentation? I'm uncertain if it's in person or virtual.
Can you hear me?
Okay, we're just waiting for the screen to light up.
It is my turn, Japanese.
Yes, we're just waiting for your picture or your PowerPoint to pop up. One moment,
yes.
please.
Okay, I'll try. Oh, I can't share my document.
Yeah, we just have to be a little bit patient in this virtual environment.
Mhm.
Ah, fantastic. Okay, we can see you.
Yeah, thank you.
And will the staff be pulling up the charts or will the professor be pulling up his charts? Sir, do you have your charts available?
Me?
Yes.
No.
Okay.
I can't.
Okay, going to plan B. Okay, okay. Oh, okay, so I'm asked if you have your charts available on your laptop. We could take a minute for you to pull those up. Unfortunately. Mhm.
Yeah, unfortunately, I
Okay.
can't share my document
Oh, I
because
see.
of the Zoom.
Okay, if it's okay with you, in the interest of time, let me just check here as the moderator. Do we have
you.
our Korea representative present and ready to present?
Hello. Just a moment. Hello.
Yes,
Yeah, this is Taekyung. Can you hear me?
yes, we hear you loud and clear.
Okay. I will share my. I want to share my presentation. So could you give me authority to share?
Yes. But I believe it needs to be on your end.
I did not receive the yet.
Excuse me, JJ. I can share my document maybe.
Okay.
Yes, we have two
You might
potential
ask
state.
for-
Can
we
I
have two
try?
Whoever has their charts ready first will be
Okay,
going.
okay, I'll try.
Our staff is
Mhm.
working to see what they come up with, but if someone can pop their charts up from your respective location, that will be the first presenter because we're running short on time.
Actually, I received the authority. Do I speak first?
Yes,
Could you see my material?
we see it. KPS and CAS. Thank you very
That's
much.
right. Yes. Okay. Thank you, Mr. Miller. Good afternoon, everyone. I'm Taegyu Kim, head of Satellite Navigation Development Strategy Team in the Ministry of Science and ICT in the Republic of Korea government. Although I attend online, glad to meet everyone. Thank you for opportunity to introduce our KPS and CAS status at the Multi-GNSS Asia Annual Conference. I'm sorry. Next slide. Yes. Just a moment.
I'm sorry, Kim-san.
Yes, right.
I make a mistake. So please try to again to share your document. I'm so sorry.
Yes. I will share again. Okay. Yes. Could you see me? Could you see my material, Mr. Miller?
We saw a picture and now we have the KPS up. So I suggest we just continue with KPS and then we'll
Yes.
go back. Okay, thank you.
Yes. Yes. First of all, I introduced our basic plan of Korean positioning system. The main reasons why we are developing KPS is to provide high precise and PNT information for emerging technologies such as self-driving car, urban aerial mobility, or many smart systems which are representative for the fourth industrial revolution. So developing a regional navigation satellite system is the most effective solution for these demands. In addition, we needed plans to provide the PNT services to meet various satellite navigation needs, such as SBAS, centimeter level service, or search and rescue. So the KPS program was started from last year, 2022, and system development is expected to be completed by 2035. The program is being governed by the Ministry of Science and ICT, which is my ministry, and the KPS R&D Research and Development Directorate was established in the Korea Aerospace Research Institute. Like the GNSS, KPS is also composed of 3 segments, which are space, ground, and user. The space segments consist of 3 geostationary satellites and 5 inclined geosynchronous orbit satellites, and it has ground track of satellites as shown in the figure on the left. 2 geosatellites have SBAS payload, and 1 geosatellite has a search and rescue payload. The ground segment consists of operation center, satellite control centers, antenna stations to communicate with the satellites, monitoring stations, and mission control stations that generate correction information for more accurate navigation services. We will also develop research and development receiver, reference station receiver, test and evaluation receiver, and user receivers. In this slide, I will explain KPS development time schedule. As I mentioned, the KPS program and R&D was started from last year, 2022. In the system and design period, SDL, PDL, CDL, and international cooperation for satellite orbits frequencies acquisitions will be progressed. Navigation signal and constellation design is also planned. After that, in the system development period, satellite and ground subsystem development will begin, and the first IGSO satellite will be launched in 2027. Finally, in the deployment and validation period, the IOC and FOC of the system are scheduled to proceed with the launch of the remaining 7 satellites and completion of ground systems. In addition, I would like to brief the status of CAS project. As you may know, the CAS is the Korea satellite-based augmentation system. The main goal of CAS is to provide APV1 service to the air navigation users in South Korea. And we expect to start APV1 SOL service from the end of this year, 2023. The CAS consists of 7 reference stations, 2 geo satellite, 3 uplink stations, 2 control stations, and 2 processing stations. CAS first geostationary satellite was launched on 23rd of June in 2022. Actually, Malaysian Niaset 3D satellite, which contains CAS payload, was launched by Ariane 5 space launch vehicle at the Kourou Space Center in French Guiana. This satellite was successfully launched to the geostationary orbit of 91.5 degree east longitude. It was designed to operate for 18 years. After launch of the CAS first geo satellite, the in-orbit test of the CAS navigation payload and CAS factory acceptance tests was completed successfully on July in 2022, respectively. The CAS uplink station and first geo satellite integration test was finished on November in 2022. And the CAS first signal has been broadcasted from December in 2022. As your future plan, second signal broadcasting is planned by the second quarter of this year, 2022. And system qualification review is scheduled for the fourth quarter of 2023. Every day, most Korean use PNT information by various smartphone applications related such as navigation, transportation, finance, online commerce, health, safety, or etc. So this is because 95% of Korean population have smartphones equipped with GNSS receivers. So I think that many people in East Asia countries live like Korean. This is because the rate of population with a smartphone is high in many East Asian countries. So importance of high precision PNT information is increasing nowadays. Korea has been conducting a number of researches to increase accuracy and integrity of GNSS-based PNT information. We hope to contribute for multi-GNSS application through enhancing interoperability between KPS and other GNSS. Today I introduced the KPS and CAS status. Although today I spoke through online, but next time I wish to attend in person and meet everyone. Thank you for your attention.
Okay, thank you very much. And our last presenter, and I apologize for the shuffle. However, for everyone in the audience, this is what happens when you don't send your presentations in on time. I will be very pleased to introduce our cabinet officer from Japan. Sir, are you on?
Thank you for introducing me. And yeah, now I downloaded my presentation, and I cannot upload my document myself, but just now I downloaded my presentation. Okay.
Beautiful. We see it.
Thank you. Thank you for stuff. Yeah. Good morning, good afternoon, everyone. My name is Kenji Numata from Cabinet Office Government of Japan. I'm Director and Deputy of Head of QGSS Strategy Office. I'm responsible for the technical management of QGSS. So first of all, I'd like to express my gratitude to all of you for participating and preparing this conference. I'm very honored to be here and to have an opportunity to introduce my recent status. Let's start. Please, next slide, please. Yes. This document consists of these 5 items. Please, next slide. Yeah, we have 4 satellite constellations in orbit, and we can provide following services: GPS complementary service, GNSS augmentation service such as SRAS, CRAS, and SBAS, and also messaging service. The constellation consists of 1 GO and 3 QGO. We have also 2 master control centers located in Hitachi Ota and Kobe in Japan. And there are also 7 TTC stations and over 30 monitor stations around the world. Next slide, please. Next, please. Thank you. It is H2A launch scene, not H3. QGS-1R was launched by H2A in 2021, and QGS-1R has been in service stability since March 24, 2022. Next, please. So this slide is the item of our new generation system, 7 satellite constellation. But I have to inform you that the launch schedule was changed. QGIS 5, 6, and 7 were originally scheduled to be launched in Japanese fiscal year 2023, but now the schedule has been changed. They will be launched sequentially from Japanese fiscal year 2023 to 2024 due to delay in development of H3 rocket. So this figure shows new schedule, and we hope that QGIS 5 could be launched in Japanese fiscal year 2023. Anyway, in the new constellation phase, PNT services using just only QGSS under certain conditions, and other new services such as message authentication, Madoka PPP, and extended EWS will be available to users. Next slide, please. And our 3 additional satellites will be placed on IGSO, GEO, and QGEO. This location aims to be visible more than 1 satellite at high elevation angle, to be visible more than 4 satellites for a long time, and to get more better DOP. This is the location of our 7 satellites. Next slide, please. And new satellites will have both the inter-satellite ranging function and the ground satellite ranging function in order to improve the accuracy of user positioning. So we can reduce the error in the along track direction and also the error in the radial direction by using the new technique. Next slide, please. So regarding the authentication, we call the service QGNMA, QGSS Navigation Message Authentication Service. We launch in JFY 2024 to enhance the resilience against spoofing attacks. And now we posted the new interface specification on our website. So please refer to the document if you are interested in our authentication service. Next slide, please. So regarding the Madoka PPP, it has begun since September 2022 for Asian Pacific region as a trial. And we are planning to perform some demonstrations. They will be conducted in cooperation with partners in Asian Pacific region to not only to promote technical understanding and also, but also consider feasibility to apply Madoka PPP to the user applications. Next slide, please. And as for QGSS EWS services, we have already distributed weather information related warning created by the Japanese Meteorological Agency since 2018 with L1S signals. We will add disaster information to the signal for domestic and Asia-Oceanian region after JFY 2024. So we are also planning to perform some demonstrations, and they will be carried out in operation with Thailand, Fiji, and Australia by the end of March this year. So what I would like to add a comment, Galileo and QGSS are working together to develop a common alert message format and promote it as an international standard. So I would like to thank you, colleagues in Galileo, for your great and productive efforts. I believe this activity can make our relationship stronger. Thank you. Next slide, please. This slide shows our R&D plan. So the direction in R&D and some technical items have been summarized for the future QGSS since Japanese fiscal year 2021. So this figure shows our tentative R&D schedule, and it has been considered until Japanese fiscal year 2032, when existing satellites on orbit will reach the end of the design life. So we have to develop new satellites, and we are now in short-term R&D period and developing some prototypes to verify new technical items. Next slide, please. And this is our applications. So as of December 2022, about 390 products are compatible with QGSS. There are lots of products applied in many industries, such as autonomous driving, buoy for real-time ocean tide monitoring, wearable terminals, and drones. And we are very pleased that the receivers, our services, are getting smaller and cheaper. Utilization of our services is definitely spreading. Next slide, please. This is a summarize. This is a summary of my presentation. UGS-1R is stable and in service, and unfortunately, QGS 5, 6, and 7 will be launched from 2023 to 2024. And utilization of our services is spreading, and also we are now conducting R&D for our future system after JFY 2033 has already started. We are exciting. And next slide, please. Next, please. Okay, thank you for your attention. Please refer to our website, and don't hesitate to contact me. Thank you for, thank you again. Thank you.
All right, so I just want to say thank you to the speakers. I want to especially thank the audience who was patient, the courtesy of sticking around and hearing all of the presentations. I know a lot of work went into them, and they appreciate that you stayed through it. 16 minutes more of your life. I think it was well worth it. And I'll just close on the point that a few of our speakers are representing nations that have joined the Artemis Accords. So in particular, Japan and South Korea. And so it's my desire that at our next MGA, wherever that may be held, we may get good news that perhaps Thailand also will join the Artemis Accords. I know that just as quite interested in that. And, you know, we really see it as a true partnership in terms of responsible and collaborative use of space. So with that, let me say goodbye so you can get to your break and have some coffee. And thank you once again.